Okay, so in this lesson we are going to look at how to interpret graphs. So here we have a graph and we can see that it's a quadratic function because of the shape of the graph. So what you can be asked to do is you can be asked to work out a number of different values on this graph. So you need to be able to look at the graph and interpret and find out these values. So the first thing we want to do is, so you could be asked, for example, to find the roots. So the roots are basically the values of x for your function. So for example, if we have a look at this, basically what we're doing is we're looking at, so it's when y is equal to 0, okay, which is here, what are the points in which x, like what are the roots? And the roots are going to be these guys here. So this one here and this one here. So what we can say is that the roots are equal to x minus 3 and so x is e, sorry, I should say, let me change this. So x is equal to minus 3 and x is equal to plus 2 or positive 2. Now what does that mean that they're the roots? So basically what it means is that if we have a look at this, so x is equal to minus 3. So what we can actually find from the roots, so if the roots, so let's say these are the roots, so let's write this down here, I'm just going to get rid of this. So x is equal to minus 3 and x is equal to 2. So if these are the roots for this function, we can actually work out what the factors are. So the factors are going to be, so if we, it's going to be x plus 3 and x plus 2. So these are the factors of it. And now what we can do is we can work back and actually work out what the equation of this line is. So x by x gives me x squared. X by 2 gives me plus 2x. 3 by x gives me plus 3x. And then plus 3 by 2 gives me plus 6. And then what we can do is we can add up the like terms. So it's going to be x squared plus 5x plus 6. Okay, so this here is the equation that describes this line. And what we can see is that it's a quadratic equation, so the x is power of 2, and we can also see that the number in front of it is positive, so therefore we have this distinctive shape on the graph. So we're able to interpret this graph and we're able to work out what the roots are, so these are the roots. From the roots we can get the factors, and then from the factors we can actually get the equation of the line. So the next question, what it asks you to do, let me just change this here, just change it the color a bit. So the next question is find f of x. So where fx equals 2. So another way we can write this, so we can say that fx, let me just change it. So we can say that function x, let me just put this over a little bit here. So what we can actually say is that fx is equal to this here. Okay, so this is equal to function x, or another way to say it is y is equal to that. So what this is asking you for, when it's asking you for what is the value of x. So when y is equal to 2, okay, what's the value of x, or what's function x? So what's function x when x is equal to 2? So what we can do is we can have a look here. And we can see that x is equal to, so we're trying to work out, so when y is equal to 2, so y is equal to 2 up here, we're trying to work out what's the value for x. So what we can do is we can draw our line across like so, until it cuts the axis, and we can draw our line down here like so. Okay, so that's about 3 there. And then we can also draw our line across here, until it cuts this axis, and we can draw our line down, and that's about -4. So what we can say is that when y is equal, or when the function is equal to 2, okay, or when y is equal to 2, and again another name for y is function x, so it can be written like this, or it can be written like this. Okay, so there's loads of different ways we can write this. So when y is equal to 2, we can say that x is equal to 3 and x is equal to minus 4. Okay, so that's the first one. So we can interpret the graph and we can work out what these values are. The next one here is saying when function, so basically what it's saying is that when x is equal to minus 2, what's the value of y? Okay, so try and work out what the value of y is. So we can see this is function x, and here we can see that it's actually given us the value of x. When x is minus 2, what's the value for y? So again, we have to be able to look at our graph, and we can see that, so when function x is equal to minus 2, so function x is minus 2, so it's down here, then we draw our line across. Sorry, when x is equal to minus 2, so x is equal to minus 2 here. So this is the x-axis. What's the value for y? So we draw our line down. We see that it cuts the axis here, and then we can draw our line across. So we can see roughly that when x is equal to minus 2, y is equal to about minus 1.5. Okay, so again, all we're doing is interpreting and taking the information off the graph. The next one it's asking you, so when function x or when y is negative. Okay, so what are the x values when y is negative? So if we think about when is y negative, so y is negative all underneath here. And let me just get rid of some of these numbers here so we can interpret it for, so let's just get rid of all these here for the time being, just so we can see the graph a little bit clearer. So what this question is asking you is, so it's basically saying that when function x, so when y is negative, so y is going to be negative all down here. Okay, so remember all underneath here, these are all the negative values. So the positive values are up here and the negative values are down here. So what you can say is that everywhere between, let's say from here all the way to here, that's when the values are negative. So what we can say is that, so when x is greater than or equal to minus 3, okay, so when x is greater than or equal to minus 3, that would include all of these values here. And when x is less than or equal to 2, okay, and then that includes all of these values here as well. So basically, if you were to pick an x value anywhere along here, and you were to draw your line down and draw your line across, you're going to get a negative value for y. So the next one then is when function x is positive. So again, where is function x or where is y positive? So it's everywhere above the line here. So essentially it's going to be everywhere, let's say, so it's going to be all of these values here. So all the values that are greater than plus 2, when x is plus 2, and all the values that are less than minus 3. Okay, so again, it's essentially this, but just the signs are reversed. So when the values are greater than, so when x is greater than minus 3, okay, so that's going to include all the values down here. So all of these values here. So if you draw a line up and you draw your line across, y is going to be, you're going to get positive values for y all along here, and then the same here as well. So when x is greater than 2, okay, so that gives you all of these values up here as well. The next one, it's asking you for, so when function x is decreasing, okay, so basically when the y value, So when the y value on the graph is decreasing. So what we can see is that all along here, so from here all the way right down to roughly around here. Okay, this is, so all of these values, so like roughly around here. So I'd say that is x is equal to minus, roughly where x is -1. So all the way from here, okay, so we're, let's say out here, x would be -4. So all the way from -4 right up to -1, so right up to roughly about here. So all of these values between these, basically the value for y is getting smaller, it's decreasing all the way along. So the values are decreasing when x is greater than -4. Okay, so let me just so when x is greater than -4, and then all the way right up to here where x is less than, so where x is less than -1. Okay, so that's going to include, basically it's all the x values from here all the way to here, because what's happening is the y value, or the function x value from here to here is decreasing. So the next one then it's asking you for is the max or min value. So again, if we have a look at this, we can see here that roughly around here, this is the minimum value. So it's going to be, so when x is -1 and y is roughly, let's say, so that could be minus, let's say -2. So you want to get roughly this point here. So that's going to be the minimum value. So there's no maximum value on this. If the curve was the opposite way, there would be a maximum value. So what we can say is that the maximum value, okay, of function x, it's going to be minus x is equal to -1. Okay, that's the maximum value. And then the maximum point would be the coordinates here. So let's say it would be -1, -2. Okay, so that's the point. So that's the x value, and that's the y value. So -1, -2. Okay, so that's the point. And like an intersecting graph would be if there's another line, let's say, going across this quadratic. So if we had something like this, so let's say we had something, so if we had, so the next one is, let's say if you had, let me just bring this up here. So if you had something like this, an intersecting graph, so this is, let's say, if you had a line going across like this, so the points at which it intersects, so it'll be this point here and this point here. And then all you'd have to do is just list that, like what point that is. So that's roughly, so -3 would be -3.5. So 3.5, and then let's say, so if this was 1, 2, 3, okay, so it'll be -3.5, 3, okay, so that'd be the xy value, and then you do the same on this side then as well. So that would be like, and this is what's known as an intersecting graph. So again, it's important that when you're looking at graphs like this, that you're able to interpret them and you're able to take information from the graphs. Okay, thank you for listening.